In this video, we're talking about the vertical line test and how to use the vertical line test to say whether or not a graph represents a function. So let's talk about a few things first. A function versus an equation. Remember that an equation is just any expression with an equal sign. So for example, if we said y equals x, that would be an equation because it has an equal sign in it. A function is always an equation. We're always going to have an equal sign in a function, but a function is a special type of equation, and for that reason, oftentimes, instead of using y, we use the notation f of x to say that f is a function of x to indicate that this is a special type of equation called a function. Now, a function is an equation such that there's only one output value of y for every input value of x, which basically just means if we were to graph the function and we choose any value of x, it's only possible to get back one unique result for y. In order for an equation to be a function, that has to be true for every single value of x within the domain of the function, for every single value of x that we can pick. So for example, if I look at this first graph here, let's say that I pick this value of x right here. Maybe it's x equals 1, x equals 2, whatever. It doesn't matter, but I'm picking this value of x. If I look at the graph here, there's only this one single value of y that's returned when I plug in this value of x. So if this were an equation, if I plug in this value of x, and again, let's say maybe it's x equals 1. If I put x equals 1 into this equation and I evaluate the equation, the value I get back for y is this value right here, which is maybe 2. So I plug in 1 for x, I get back 2 for y, and there's only one result for y. On the other hand, though, if I pick this value of x right here, maybe let's say this is -1, and I plug it into my equation, I can get back two possibilities for y. I can get back this value for y, and I can also get back this value for y, because I'm plugging in this same x value. If I draw a vertical line here, I'm plugging in this same x value, but there's two y values that can be returned to me as a result of plugging in that x value. Since there are two possible output values for the single input value of x, this graph does not represent a function. Even though this relationship right here is 1 to 1, I plug in one x value, I get one y value. As long as I can find any single x value that could possibly return to me two different y values, then I know the graph is not a function, which brings us to the vertical line test. Basically, all I'm doing right here is I'm testing different values of x, right? I can pick all these different values of x, and I can look at the graph, and I can see which y values are returned to me. You know, this y value is going to get returned to me when I plug in these different values of x. If I ever find a point for x that returns to me two different values for y, then I know that the graph does not represent a function. And basically what this is saying is that if I can draw any perfectly vertical line that intersects the graph at more than one point, so I can draw this perfectly vertical line and I can see that it crosses the graph at 2 points, 1 point here and 1 point here, that means that for this single x value right here, I can get back two different output values for y. So this graph does not pass the vertical line test, and therefore the graph is not a function. In other words, a graph must pass the vertical line test in order for it to be a function. So if I look at this graph right here, I can draw a perfectly vertical line right here, and I can see that it only intersects the graph at this single point, so I know I'm okay there. If I draw a perfectly vertical line here, I can see that it only intersects the graph at this single point, and I can do that for lots of different vertical lines. But if I draw a perfectly vertical line right here, I can see that it intersects the graph at 2 points. This point right here, which is off of the graph, and this point right here. So because of this other point right here, this graph does not represent a function because it does not pass the vertical line test. It doesn't matter if I can draw a million vertical lines that only intersect the graph at one point. If I can draw one single vertical line anywhere that intersects the graph at more than one point, the graph does not pass the vertical line test and therefore is not a function. So here's what I would want to say. I'm going to go ahead and say not a function here, and this is also not a function. What about my third graph right here? If I try to draw vertical lines, and again, I can draw them anywhere I want to pick, but if I draw vertical lines here, maybe here, I can see that each vertical line that I draw is only going to intersect the graph at one single point. There's no vertical line I could draw on this graph that would intersect it at more than one point. Therefore, this graph passes the vertical line test, and I can say that this graph represents a function. If I look at my last graph here, I can see that I have a circle, and right away I can tell that I'm going to be able to draw a bunch of vertical lines that intersect the graph at more than one point. So I have this line here, I have this line here. I can draw it closer to the edge of the circle, and I still intersect the circle at 2 points. So what this tells me is that this graph does not represent a function, and in fact, I can conclude from this that a circle is never a function because I'm always going to be able to draw a vertical line that'll intersect it at more than one point. So a circle is never going to be a function, and this graph certainly does not represent a function. So that's how you use the vertical line test to say whether or not a graph represents a function.